In this video, I'm going to be discussing how real-world data can actually be predicted using linear models. Jacksonville, Florida has an elevation of 12 feet above sea level. A hot air balloon taking off from Jacksonville rises 50 feet per minute. Hint, that is actually going to be your slope. Anytime you have a rate of change, you will have a slope. Write an equation to model the balloon's elevation as a function of time. So what you're going to do, which we have discussed, y equals mx plus b, is writing a linear equation. So basically, when the hot air balloon is on the ground, they're technically already 12 feet above sea level. And then from that point, it rises 50 feet per 1 minute. So to graph this, again, if you think of slope as feet per minute, which means it rises a certain number of feet for every certain number of minute, which means feet is going to be your y-intercept, and your time, or in this case minutes, is going to be your x-intercept. So the balloon, when it's actually on the ground, is already 12 feet above sea level. And then from this point, it's going to rise 50 feet for every minute. Now, whenever you connect these dots, you normally would draw lines in both directions. However, this means that there's negative number of minutes, which you do not have in a real world situation. So this is actually how you would graph it, and you would not graph the left-hand side of it. The intercepts for this basically mean that at time 0, you are already 12 feet above sea level. And then you can rise from there. That would be your function of time. Sam is heading to school from her house. Interpret the graph. So at 0, she is at her house and she is heading towards school. Now the distance from here to 1 means that each of these represents 0.2 because there's 5 spots going to 1. So this would be 0.8 to 0.6. Okay. So if you want to interpret this, she is traveling. She starts here at home at time 0, and she travels for 5 minutes. And she travels 0.6 kilometers in 5 minutes. So if you want to interpret that, you could say she got in her car and she drove 0.6 kilometers and it took her 5 minutes. Maybe it was a bike that she was on, but she traveled a certain rate of change. Now at this point, she's not getting any closer to school. She is the same distance from her house for this time period between 5 minutes and 15 minutes. So she stays, I guess you could say she stays the same for 10 minutes. From 5 minutes to 15 minutes, she stayed the same. If you want to interpret the graph, you could say that maybe she got in a traffic jam and she had to sit for 10 minutes. She could have been at the bus stop waiting for the bus for 10 minutes. And then the second slope, she starts traveling again. So from 0.6 to 1.2, so 0.6 to 1.2 is another 0.6 kilometers. And it took her, let's see, from 15 minutes to 20 minutes. So she traveled another 0.6 kilometers in 5 minutes. So again, she could have been riding her bike again. She could have been walking again. She could have been in the car, but she is traveling another rate of change. So you can determine the fact that she made it to school, which was 1.2 kilometers away, because you're going from 0 up to 1.2. And it took her 20 full minutes to get there. She was moving for this 5 minutes and this 5 minutes. So she was moving for 10 minutes and she was stuck or waiting or sitting for another 10 minutes. Next, real world. The graph shows the height of a candle as it burns. Interpret the intercepts. So we know that this is time, and we know that this is the height of the candle because it says the height of a candle as it burns. So it takes time for it to burn. So this coordinate point right here is 0, 9. That basically says that the candle, basically at the very beginning of burning, the candle is 9 inches high, centimeters high, we're not sure, but it is the height of the candle at the very beginning. And then it burns, so obviously the candle shrinks, and then at time 4.5, what do you think happens? The candle is pretty much gone. It has completely shrunk down. We have burned the entire candle. The graph itself is basically a slope. So if you were to go from this coordinate point to this coordinate point, you would go down 2 and over 1. So therefore, it is decreasing in height for every 1 minute or hour. We're not sure what the time is, but we do know that it decreases in height by 2 for every 1 time in the time. So if we say that it's inches in minutes, then we could say that the candle decreases in height by 2 inches every 1 minute, maybe every 1 hour. It depends on what the units of measure would be in this case. But you can still interpret a graph and interpret a slope based on what it's doing with the candle. Next, real world. A candle is 7 inches tall after burning for 1 hour, and then 5 inches tall after burning for 2 hours. So time is always the independent variable, and the height is based off of the time. So the height is going to be the y coordinate. So we know that after 1 hour, it is 7 inches tall. And we know that after 2 hours, it is 5 inches tall. We actually can create a slope from this. So the slope is y2 minus y1 over x2 minus x1. So if we do 7 minus 5 on top, then we do 1 minus 2 on bottom, which is 2 over negative 1, which is negative 2. And it should be negative because the candle is decreasing, which is what it should be doing. So we know that the equation is going to be y equals negative 2x plus b. Now to find b, we are going to take one of our coordinate points. I'm going to take 1 and 7. I'm going to plug 1 into x because that's my x coordinate, and I'm going to plug 7 into y. So I'll get 7 equals negative 2 times 1 plus b. So 7 equals negative 2 plus b, so therefore b equaled 9. So therefore my final equation is going to be y equals negative 2x plus 9. Now, what exactly does that mean? Well, we know that it starts at 9 and the slope goes down 2 over 1. Now, I am not going to finish my graph all the way through because you cannot have a negative height. So the graph actually stays in the first quadrant. 9 represent how tall the candle is before it begins to burn. And then this x-coordinate intercept at the bottom is basically how long it took for the candle to completely burn. So this is the beginning before it burns. This is how long it takes to burn. Scatter plots. Now there's going to be many times to where you have a bunch of different coordinate points, but whenever you plot them, you can sometimes see a correlation. A few of these have correlation, some of them do not. The plots that have coordination would be this one. There is a correlation. There is a what you would consider a negative correlation. This one would be considered a positive correlation. There is no correlation here. There is no correlation here. But this would be a strong correlation, a strong positive correlation. And this would be a strong negative correlation. So anytime you have a real world situations, the scatter plots can help you to determine an estimation of what a value should be. For example, maybe back over here. A carpenter recorded the amount of money he earned for different jobs and the amount of time he spent on each job, and they plotted those points. Based on the data, which best represents the amount of money that the carpenter would earn from a job that took 5 days? The days are the x coordinates, so if you look at 5, you got to figure out about how much did he earn. Well, if you plotted these points and drew a rough linear equation through these points to create what you think a linear model would possibly look like, you can then determine roughly somewhere in this part for 5 days what his amount of earnings would be. So if you look at the Y values, that means he probably would earn anywhere between $1,250 to $1,500. Probably not $1,500 because that would be up here, which is not really on close to the line. It's probably going to be somewhere closer to $1,250. Next, a trend line can also help you determine. So Mo's mowing service, for every hours that he mowed, this is the amount of cost that he earned from mowing. What could you determine from this graph? The more you mow, the less money you make. Well, less money means that the slope would be in a negative direction. That does not occur. You make the same amount of money regardless of how long you mow. So that means that if I mowed for 1 hour, I would make $6. If I mowed for 8 hours, I would still make $6. That doesn't seem to be an interpretation of this graph either. The more you mow, the more money you make. Well, let's see. If you mow 1 hour, you make this amount of money. If you mow 5 hours, you make this amount of money. That seems to be correct correlation. The more you mow, the farther you go this way in mowing, the more money you would make. That is true. So in this case, this trend line would be represented by that explanation.